So here is the feature complete Trellis soundbox. The last part of what I was working on was so there are two modes for the box. There's a regular note playing mode. You can pop it on. Actually, let me turn it up. So there's whenever you turn on, there's regular note playing mode. And then there's also a memory matching game mode. So I was trying to figure out the best way of switching between the two modes, and I didn't want to add more hardware, but I knew that I had like a perfect programmable interface for switching the modes. So I added a secret code for it. So if you put in the correct code, which is it switches you to the memory matching game. So, and it'll just keep running. It'll keep randomly generating notes until you get something wrong. It'll show the fail state, and then start out with a new random note. To get back to the regular music mode, you just turn the box off and back on again, and the conditions reset, and you can play again. So the way that I added, let's see, so get a little bit closer. The way that I added in the secret code was so if we look at my main.py file, I'm bringing in all the libraries. I'm initializing the trellis, the speaker, firing the startup chime, grabbing some information that's needed, and initializing the matching game. So I added a couple of different global variables, specifically a secret code, a check index, which is essentially a pointer to what part of the secret code we want to check, and then a boolean for whether or not the gameplay is enabled. After that, we go through the regular reading in the buttons, seeing what lights and what sounds we should fire or not fire, and then we get down to the lower section, where whenever a user lets go of a button, we want to evaluate whether or not we want to enable gameplay. So I'll skip this first conditional and go down to the second part. So whenever we're first starting out, gameplay is not enabled. So we see if the user has pressed the button, and then based on whatever our code check index, which is 0 at the moment, is, we'll look at the secret code and see if the button matches that particular part of the secret code. If it does match, we'll increment the pointer, so it'll go to the next part of the secret code. If it's wrong, then we'll set the pointer back to 0. So if you put in the correct first two digits for the secret code, but then you mess up on the third one, it'll just reset you back to 0. So after we do each of those increments or resets, we'll check to see if the pointer is currently the length of the secret code. And if we've gotten all the way to the end of the secret code, we know, oh, it's time to turn on gameplay. So we'll enable the gameplay, we'll play the success state just so that we get a visual and audio indicator that you're now playing the game, and then we initialize the game and start over. So the next loop through, whenever the user presses the button, now we're checking to see if gameplay is enabled, and it has been enabled, so we could just pass all of those user presses through the gameplay evaluation. And because we have gameplay enabled, now none of this logic will fire, so this is essentially done. And that's it. There's nothing else there's nothing else to it. It's a pretty simple switch. And because we are evaluating the successful input of the entire code using the length of the secret code list, it means that this secret code could be anything, any of the indexes within our range of button indexes that we want, and it could be any length. All we would have to do is adjust this list here to change the secret code. And that's it. So the 3D modeling is done. There may be some adjustments that I make for the battery cover so that it sets in just a little bit better. But really the modeling's done, the wiring's done. I've actually resolved the issue. I was having an issue earlier where if I turned the volume all the way up, as soon as you press a button, it would freak out. So that part's been resolved, and really that was, I don't actually know what resolved it, but I know that when I switched from C to CircuitPython, the issue went away. So the next step for this is the version that's going to sit on my desk as an example, and the next step would be to make the version for my daughter and for my nephew. And I'm going to go through and record all of that and show the process of actually assembling this and turn it into a tutorial, open source everything, and call it a day and move on to the next project. So it's really nice to get to this point.